I know I've warned you away from undercuts and explained why they won't work in a standard bivalve mold, but what if your design absolutely requires it? Many parts require additional moving pieces as parts of the mold, which adds cost for every additional pull. They go by a few names: side actions, cams, and side pulls. I like to call them pulls because there are pieces of the mold that hold in place during injection and pull away so you can eject the entire part. They pull perpendicular to the face they're pulling away from, but they also need their own draft in relation to that face. The pull is like a tiny simplified mold for specific features on your part. It needs draft in relation to the direction it's being pulled. Usually, pulls leave a mark, so if that bothers you, try to incorporate the shape of your pull into your design. The part end of the pull should match the curvature of your part, even on a part with drafted walls like this. Pulls enable you to have undercuts. Be mindful of designing a part that just has a bunch of pulls, because every added layer of complexity to your mold costs you the big bucks. In addition, each pull is another piece of the puzzle that can fail, wear, or not meet your standard tolerance. The main purpose of pulls in general is to enable more complex geometry by holding in place during a cycle and pulling away so the part can be removed. Let's look at a draft visualization of this clip for the sake of argument. Parts that have clips require something a little extra. Think about it. The two parts of the die pull apart along the up and down axis, as shown. How can we get this clip in here? You'll need a pull. Let's see what that pull looks like. Cool, right? For a catch like this, you can add a pull, which would be this block, in a number of ways. If you can get away with it, you can make a hole right below the clip, and so the pull would be part of a main mold half. Let's say you can't put a hole right here though. Time for a handy cam. From the side, this pull makes this feature follow the rules of draft for part removal. So when the part is done, the robot moves it out of the way, easy peasy. While you're working out the details in the prototyping stage, you could also use something called a pick-out. Before casting, these individual pieces are placed in the mold, and when your cast is complete, you pick it out. Because this adds time to every single cycle, it's not the quickest solution to your undercut problem, but can be helpful prior to having the final mold made.